Number 15 is supposed to be the hardest question in this section, but because of the way it's phrased, it's actually really, really easy. Notice that all of the answers are potential values for x. So I don't need to do some elaborate algebra to find those values. I can just test out the ones that I'm given and see if they work. So this is a clear example of guess and check. Make your life easy. Avoid algebra. I'll show you why we should avoid algebra at the end. But for now, let's just take the points. I'm going to use x equals 2 first because it's a little bit easier. So I don't want to have to deal with the negative on top of everything else that's going on. So that would just mean we have 2 plus 2 under the radical is equal to negative 2. So 2 plus 2 is 4. The square root of 4 is 2. Now, as it's written, we can see that 2 does not equal negative 2. So that means that it's wrong. But I want to talk about why, because I think this is a mistake that I made the first time I saw a question like this on an SAT. Is I thought, well, the square root of 4 is 2, but it's also negative 2, right? Because negative 2 squared could be 4. So that's kind of confusing. What's going on there? Well, here's the thing. The way that the SAT asks these radical questions, we only need the positive root. It has to do with the way that they explain at the front of the test that everything is a function. And so when we have a negative root, what's really happening is we don't have a function. So I don't think you need to really understand that. Just kind of take my word for it. That when we're doing stuff like this, the positive square root is the only one that counts. Okay? So it's frustrating if you got it wrong for that reason. At least here you're learning your lesson. Yes, it's the hard way, but yes, you're learning your lesson, and I promise you it will be the same on another version of this question, on another test. It'll be the same. So 2 and negative 2 are different, and so we can cross out choices A and C. Now we just need to test negative 1, because if that doesn't work, then D must be the answer. But let's see. X equals negative 1. So that's the square root of negative 1 plus 2 is equal to negative 1. Notice how I'm putting those parentheses there because I'm afraid of losing negatives. So I do a lot of little things along the way to make sure I don't lose them. In this case, same kind of issue here. Negative 1 plus 2 is 1. And negative times negative means a positive 1. And so yes, the square root of 1 is 1. So there we do have a positive and a positive. So that means that B is the answer. And that is the answer. So guess and check here I don't think takes very long. And as long as we know this one particular fact about the square root of 4, we can get this right. Now let me show you why algebra is not a good idea. So what happens if we see this as an algebra question? Well, we start probably by squaring both sides to get rid of the square root. So we get something like x plus 2 is equal to x squared, right? Because squaring that negative makes it go away. And then I would subtract everything over to this side. So that way I'm not dealing with a bunch of x's all over the place. I have a quadratic equation where 0 is equal to x squared minus x minus 2. And then I got a factor. So I need something that multiplies to negative 2 and adds to negative 1. So that would be negative 2 and positive 1. And when I solve each of those factors, I would get that x equals 2 and x equals negative 1, which was the trap answer in choice A. Now, we just did valid algebra. Everything I did in light blue is correct. I didn't make any mistakes. And I got an answer where it seems like it matches with choice A. So what's the problem? Well, the problem is when you have radicals in algebraic expressions, they cause problems. And what we need to do after we've solved anything with a radical is we need to check for extraneous solutions. You've probably learned it, maybe you call it something different, but extraneous is just a fancy word for extra. because sometimes what happens with square roots is they cause an extra number to pop out at the end of the equation. And it may work in all the algebra that we did, but it doesn't work in the original expression that we had. It's just a weird thing that happens with radicals, mostly because of negatives. So this is something you need to get in the habit of checking for in school when you have radicals in algebraic expressions. And how would we check for extraneous solutions? Well, we would take our two answers and we would plug them back into the original expression. But guess what? We just did that. That's what guess and check is. So here's a great example where the real textbook way to do the math question is way more inefficient than the SAT strategy. Because the SAT strategy omits all this algebra, and it prevents you from accidentally forgetting this extraneous solutions thing and picking a trap answer choice. So look, some people resist the strategies. I don't know why. Sometimes they get you points you might not get otherwise. Other times, they are more efficient. So look for opportunities to guess and check. You don't need to find every X if the X's are given to you in the answer choices. Just work them back into the question. Guess and check is a very powerful tool if you know when to use it.